Okay, we're going to apply trigonometry. To do this, we will need to draw a diagram, even if there's sort of one there already, I'll show you, and label the key information. The key information is things like the opposite side, the adjacent side, the hypotenuse. We need to find our right angle and our right angled triangle and draw that separately. And we'll use trigonometry to find the missing measurements. This is real important. I'll put a little star on this one. Remember that you have to say exactly what it is. You have to, because they're word problems, you have to say, what is this answer, therefore? We'll use the therefore. In this one, we'll talk about an angle of elevation. So if we're at sea level, let's say, or that's the flat surface, we can get an angle of elevation from a point, say point P, and it's going up. And say if we're up here on a cliff face, or if we're somehow on a tower, and we can look down toward the sea or the ground, and we can find our angle of depression. And don't be afraid, because really, because of our knowledge of parallel lines, you might be able to see here that this angle of elevation is going to be equal to this angle of depression, because they are alternate angles. So we're going to use that to our advantage. Firstly, the point on the ground is 30 meters away from the base of the tower. And from there, looking up to the top of the tower, that's a 28-degree angle. So we have a nice little drawing there that can help us already. Find the height of the tower to the nearest meter. So let's just redraw it here and just make sure that we've labeled everything the way we want to. So this, okay, we know that that is 30 meters away. Our tower, we want to know the height of that, and we don't. It's dangerous, isn't it? If we put a h there, there could be hypotenuse. Let's make it an x. And we know that this is 28 degrees. Of course, that isn't the hypotenuse, because if we look, that is opposite, and this is adjacent. So we're going to end up using tan. So tan, 28 degrees is the degrees we know, is the opposite over the adjacent. So tan 28 degrees is the unknown over, and that could be anything. I just changed it to x so we wouldn't get confused. And that is, of course, tan 28 degrees. So using our algebra, I'm going to multiply the left side by 30 to give me x by itself. So that'd be 30 tan 28 equals x. And I'll just flip sides because I can. And let's see, we want this to the nearest meter. So it comes out as 15.9 something, so that's 16 meters. So then we have to write, therefore, and you can write this legibly, the height is 16 meters to the nearest meter. No, not very tall. Top of the tower is 16 meters. Okay, now we definitely need to draw this because we don't have anything to go on. From the top of a vertical cliff. Okay, here's my vertical cliff. Andrea, here's Andrea. You don't have to draw Andrea, but, you know. Oh, she needs arms. Okay, Andrea spots a boat out at sea. Here's the sea. All right, I'm being silly. Here's the sea. There's our 90-degree angle, I think you can see. And she spots a boat. The top of the cliff is 42 meters above sea level. So we know that this is 42, and the boat is 90 meters away from the base of the cliff. And so find Andrea's angle of depression to the nearest degree. So we know this is there, but we don't know what it is. So now what we need to find is the angle of depression. So don't be fooled into trying to find that angle. No. So we're looking for this angle, the angle of depression from Andrea's point of view down towards where that boat is 90 meters away from the base of the cliff. So what we have is an alternate angle. If we think of that dotted line as parallel to sea level at 90 meters, and now we can start our work. So again, we've got opposite and we've got adjacent. So with opposite and adjacent, we're dealing with tan. So tan theta, we're going to have to figure out what theta is equal to the opposite over the adjacent, which is, in this case, the opposite is 42, the adjacent is 90. So tan of theta is this, but we want to figure out what theta is. So theta, that angle, is going to be that inverse. We're going to use that inverse button on our calculator. We're going to use our second function and get the inverse operation of tan and multiply that by 42 over 90. And you can use your ABC button to get that. And what are we looking for? To the nearest degree. So then theta is equal to 25 point blank, 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 25 degrees to the nearest degree. So, therefore, we've got to answer a word question with words. You write more neatly than I do, please. The angle of depression is 25 degrees. And we'll even put in for good measure to the nearest degree. Okay, and now this one we got to do a little bit of gymnastics here. So, this one's going to be really useful. I can't tell you the number of times that I've been flying a plane at an altitude of 1,500 meters. Okay, so we're 1,500 meters off the ground. And in my plane, I start to climb at a steady angle of 15 degrees compared to the horizon. So now we've got an angle of elevation we're looking for. When the pilot, me, sees a mountain. Yoinks! So we've got a mountain there. And the mountain is 2,120 meters high off the ground. I'm not on the ground. And it is 2,400 meters horizontally away from that point. So the question is, will or will I not clear the mountain? This is life or death, people. Life or death. So let's redraw this. Before I do, I'm going to use the drawing I have. And that I'm going to need this number, 2,400. Can I use this number? Because I am already 1,500 meters up. So I'm going to come in at my right angle here, and I'm going to see at 15 degrees, am I going to make it? So I kind of need to know some more information. So let's redraw. So I've got some information. I know that it's 2,400. I don't yet know what that is. It's some portion of 2,120 because I'm already 1,500 off the ground. So let's just remember, let's just remind ourselves that we're already 1,500 off the ground. That's just a little reminder. And here we'll do a connection, and our angle that we're moving from this point, 1,500 meters off the ground, we're going to go up, 15 degrees. All right, so what are we dealing with? Oh, look, x is the opposite. This is the adjacent. Our old friend tan is back. So we know that we have tan 15 degrees is equal to, do I need to write it? Opposite over adjacent. And now this one's easy to solve for x. We multiply both sides by 2,400 because we were dividing it by x, and that'll give us x. So if we use our calculator, we'll find that x is equal to 643. Does it tell us to round anywhere? Away from the... Well, it's 643.078, right? Well, let's look. So that's exactly what the number is, but that's not the answer to the question. The answer to the question is, will the pilot clear the mountain? Tune in next week. No. So we know that that X amount is 643 and change. So what we need to do is take the total. So that's the height. This is the height of the mountain peak. And we'll take away how far we already are above ground. And that gives us 620. So we need to be able to clear 620 meters. And at the rate that we're climbing, we're actually going to clear 643 meters. So we're going to do it. Thank God for that, because I have theater tickets next week. Since x is greater than 620, our plane will clear the mountain peak. Okay, there you go.